So, if you guys remember last time, what we did, first we calculated base flood losses without increase. Oh, yeah, oh, sure. No worries. Get into it very quick. Turn up the volume. That good? Okay. All right, so last time we started talking about flood mitigation and how we can model the impact of flood mitigation. So we did the process in multiple steps. First, we started with one mitigation measure, which is the flood barrier, and how we can know the impact of this mitigation measure. We need to calculate the flood losses without any mitigation. We call this case base flood loss analysis, and then we went in the function with the same flood depths without any mitigation measure, and we calculated the losses at each flood depths for each building. And once we calculate it for each building, we can make a sum building by building to get the total flood loss at the community level. Okay, so that's the first step. Second step, we made a for loop that can go building by building. And if you guys remember, we had a number of flood barriers. We had like 5 flood barriers. Each one is like 0.2 meter, 0.4 meter until 1 meter height. There's some flood barriers like 1.5 meter, but the thing is, the more height that you have, the more cost that you have to spend for the acquisition of this flood barriers. Okay, so the thing is, for this analysis, we only have done. Okay, like we said we are gonna use, just listen for your record. We said we are gonna use flood barrier, right? But we didn't calculate the cost of the barrier. Let's say we're gonna build a flood barrier that is gonna cost, I don't know, like $50,000. Like Walmart is gonna build a flood barrier of 2-meter height around the whole Walmart, and it's gonna hire a company. There's companies that can do this for you. There's people, by the way, the technology of the flood barrier got enhanced recently. There's some that are very cheap. There's some that are like L-shaped plastic. And the thing is, they depend on, like, let's say that your house is here. Okay, and there's flood barrier, something like this, have an L shape. And they basically depend on, once the water get flooded and it's here, the water is here is gonna make weight and it's gonna balance the pressure from here, so it's not gonna flip. So, and actually it's like 1 meter, the section is like 1 meter, something like this, and you can clip them together. So that's one way to do it. I saw some videos about it and it's cheap. There's some of them, it's called the bladder dams. It's like a tube of a bag, like let's say a plastic bag, but it's a tube section, and you fill it with water. And once you fill it with water, maybe you fill it with the water like the tap water, or you fill it from the water from the flooding. Like once it's flooding, you have a pump, you pump the water inside the tube, and the tube is gonna get filled, and all this tube is gonna be around your building. It's not gonna let the water, and it's not that expensive. Like some people will buy for $5,000 or $10,000, depends on the length. And they keep it for emergency. That's also one way to do it. There is like advanced ones. Like I remember when Hurricane Milton hit Tampa, a hospital there hired a company to build a flood barrier, but it was really like strong one, because the height was like 4 meters around the hospital. It cost the hospital $5 million to build it 2 days before the hurricane. And if you look at the videos from Hurricane Milton, you will find that the water like is almost about to overload the height, like was like 4 meters, and the water depth was like 3 meters. But can you imagine? Yeah, you will say, oh, they spent $5 million, but how much they save? Not only in monetary or in financial savings, but the hospital is an emergency facility. They need it to be function, so it has social and economic impact that you cannot feel it, but can be felt different way. So and the idea from what I'm saying right now, that we said that the household is gonna apply a flood barrier. But the thing is, what is the cost of the flood barrier? So when we talk about the loss reduction and the cost of the barrier, we need to optimize between them. Like sometimes, okay, I'm gonna build a flood barrier, but the flood barrier is gonna cost me, let's say, $20,000 to save $10,000 of savings. So it doesn't make sense. So if we want to know what is if what we are doing is efficient or not, we need to calculate the cost of mitigation and do some optimization and see if that's actually a really good point of research. Like if you want to continue from here, I have done, like I built on this work and we did mitigation and we did all of that, but not all the mitigation measures. So we like say, and also this is restrained by the budget. Maybe the household doesn't have money. That's why I told you, we need to have maybe 10% of the household to apply this mitigation measure, because maybe the household is old, like they are very old, like in their 70s, they can't do it. Or they cannot hire people to do it because it's very expensive. Or they don't care, like they are rich, gets flooded, we are gonna recover, whatever. So they only think about that they need to go outside from the flooding, and after the flooding, they are gonna think about how they recover their house. Okay, that's why we are doing the 10, 20, 50% to simulate the social behavior of the people. Okay, so that's about the flood barrier. And it was actually an easy step. It was like, I don't know, like 50 line or 100 line of code, and all of them are similar to each other. And once you finish for 10%, you can do the 20 and 30%, but just like copy and replace, right? That's what we did last time. So today we are gonna see how the impact of flood duration can impact the damage. And you guys tell me, for flood duration, how we can decrease the flood duration, no? I talked about it before. Like, let's say the flood is gonna stay for 2 days. What equipment that you need to use to bring the flood duration from 2 days to a few hours? A pump, right? We said that the only way that you can decrease the flood duration is the pump. You have to get a pump, you pump the water outside of your home so that you can increase the flood duration, because the more the water are gonna stay, the more it's gonna cause damage to the foundation, the more it's gonna cause damage to the wood, the more that it's gonna cause damage to the things that are not water sensitive. But there's some components, once they got touched with water, they are gone, okay? We talked about this before. So let's see how flood duration is gonna be modeled into the mitigation. If you guys remember, we have, let me go to the, yeah, this one. This is the flood barrier. Like if you guys remember from the for loop, we said if the flood depth is less than the barrier, so the losses is 0. But if it's more than the barrier height, you are gonna jump back to the curve, okay? All right, so the impact of flood duration. So as I said before, we are not doing damage analysis, we are doing loss analysis. So we're not using the fertility, we are using the loss rates, yes.
So about the flood barrier, think about the cost after reaching like 2 meter or 3 meter, there would be no difference. Even you're gonna be losing more. What's the barrier as you did before?
Yeah, like what I'm saying is you are putting a 1 meter high barrier.
Yeah, but after
that, the losses is gonna jump back.
same as before.
Like, yeah, you're gonna jump. Look, this curve is this curve, but I came at 1 meter and I make all this value 0. See, all this, I truncated this section. All right, but once the water height exceeds the barrier and jump, so the water depth is gonna be, that means the water depth is more than 1 meter, and you are gonna jump back to the curve, the original curve that you had.
How come it's that? I mean, if you reach maybe up to 4 meter barrier.
No, right now I'm saying 1 meter barrier.
So there's a difference.
Yeah, that's the case that we have from there. Like we said, if it's 0.2 meter barrier, so this section is gonna be here. This is just an example for 1 meter barrier.
I mean, after, let's say I have a 4 meter barrier. And
It's gonna be a different curve.
yeah, but after the 4 meter, it's gonna calculate at the beginning, as the same curve, right?
Yeah, like if you have a 4 meter barrier, so all this is gonna be 0 and your curve is gonna start from here.
Yeah, but how is that possible? Like after reaching more than 4 meters, it's gonna accumulate loss directly. Like, that's what I mean. Like,
Okay, so let's say your house is here. Right? And you have a 4 meter barrier like this, right?
Yeah.
And the water is here.
So after.
So if this barrier fall, all the water is gonna be here.
Okay, so you assume the barrier falling, it's not reaching height and.
Yeah, like the barrier is gonna fail because this barrier can take a specific load. The load is gonna be more than the barrier, what the barrier takes.
I see now. Yeah.
Yeah. And we are talking about a flooded home and an entire community filled with water. So this thing is nothing with respect to the amount of water behind the barrier.
That would make sense if the barrier.
Yeah.
Yeah, I thought.
Well, the thing is, for these cases, that's still a simplification, because if you want to actually simulate what is exactly happening at the community level, you have to model all these barriers in the hydrodynamic models and see how is the water flow behind them. Because this barrier, like this area that doesn't have water, so when the water flows behind them, there's a hydrodynamic effect that can cause the damage to the barrier. There's a lot of stuff that can affect the barrier functionality. But right now, we simplified the problem. We said, if you have the water depth is more than the barrier height, so the water is gonna keep falling. Either the barrier didn't fail, or the barrier is still in place, because the water is gonna keep filling until this is all filled with water, and then it's gonna move away, like.
Yeah, but if the barrier didn't fail, it's not gonna accumulate loss in this way.
No, it's gonna accumulate. The thing is, okay, let's say the water is gonna reach here.
Yeah.
Okay, so you wanna say that the water is gonna be like this and the water here is like this?
Yeah.
No, it's not gonna happen. That's never gonna happen. The water is gonna always go from the highest place to the lowest place. So this water is gonna keep going until it's filled, and all of them reach almost the same elevation.
Okay, so
Like, that's the same thing with the community. Your community is something like this, like the ground is something like this. So when a flood happened, it almost reached same elevation. So most of the communities that get flooded, the water surface elevation is almost horizontal. Something like this, except because if there's some structures around the community, like hydraulic structures or something that can make differences in this. But mostly, if there's no hydraulic structures and it's an open surface and the water gets flooded, the surface take a specific level. Because the water is under gravity. So the thing is, the water is gonna take the same level and the flood depth is different because of the ground. Same thing here, the water is gonna take one surface. Because the water is gonna go from the highest potential energy to the lowest potential energy until it gets to yeah.
move that.
And all of this is because of the potential energy.
I see that. That makes sense. Thank you.
All right, absolutely. So, let's get back to the flood duration. So for the flood duration, what we are gonna do is, I'm not sure if the household is gonna use pump or not, right? That's something I'm not sure about it. So, and I'm not sure how long the pump is gonna work, how strong is the pump? And sometimes some community, they have really big pump. I'm talking about big pump, like big as this room. Like there is a big truck, transform them and put them, take water from inside the community and pump it to the river. Like the one in Lumberton I showed you, I'm not sure if you remember or not, there was like a series of pumps sitting on the levee, taking the water from the community and pumping it to the river. Okay, so whatever the pump you are gonna use, I don't care. What I'm caring about right now, how long the water is gonna stay inside the house, and in terms of flood duration. What is the flood duration? How the water is settled inside the house. So I made some simulation. I said I'm gonna have a simulation of the flood duration for 1 day, 2 days, 6 days, 8 days, and 10 days. All right. So for each one of these, I'm simulating the impact of this flood duration while everything is the same. Like I'm not using flood barrier right now. It's only flood duration. So we have the base flood loss. Actually, the base flood loss is this curve. That means like this curve is almost close to the base flood losses. Like, because if you guys remember when we developed the base flood losses with like the 2D one, we didn't account for the duration, right? But my assumption to develop this 2D that the water is getting to the maximum, like once the element got touched by the water, it's gone. Okay, so that means that the water is gonna be damageable, whatever the flood duration is. So that is almost because the 2D was like at 300 hours, like, but this one is like almost the one at the 300 hours. They are almost the same. Like here, the values here is just a little bit from here. Okay. So what I want to do is, if you guys remember from the base flood losses, basically we interpolated the loss, like we said, okay, take the flood depths. Let me get the 2D function. Not sure if I have it here. Yeah, here. I said, read the flood depths and read the total losses, and I'm gonna give you the flood depths at each building and go inside the curve and interpolate and get the value of the losses at each building. That is the base flood losses. So what I'm gonna do different right now, rather than asking MATLAB to interpolate in one curve, is gonna interpolate for each scenario. So go in curve number one when flood duration is 1 day and interpolate for the flood losses. So if let's say that the flood depth is like 2.8 meters, so it's gonna get here and get that amount of flood losses. And if the 2 days get the amount of losses, 6 days, 8 days, 10 days. Let's say the flood loss here is like 40 or 30%. So here's gonna be 35, 40, 50, 60. So the flood losses is getting increased as soon as the water is staying there. So this is the base, right? If you want to calculate the flood loss reduction, you need to subtract this from this. From here, you need to subtract for each scenario. And we are gonna do the same sequence that we did for the flood barrier mitigation. If you guys remember, we did 10%, 20%. So we are changing the percentage of the population that are implementing these mitigation measures, and we are changing the flood duration to parameters. So let's see how we can do it in MATLAB. If you guys remember, to do this, I have to. Okay, so I have done all this, all the barriers last time. Now I'm gonna. Oh, that's barrier and flood duration, both of them. All right. So I'm starting verse by 10% of the population or 10% of the households are gonna implement the flood barrier. By the way, it's the same MATLAB code that we started last time. We are just building on it. All the shape files like S10, we read this from previous simulation. I told you, I gave you, did you guys check that drive folder that I gave to you? It has all the shape file, 10%, 20%, it has the Excel file, it has some codes and everything. So we already read the shape files for each scenario. Okay, if you guys open the shape files at ArcGIS, the 10 of them, you are gonna find some of them has like 280 buildings, some have like 500, whatever. So they are different building numbers. Why? Because they are percentage from the total flooded buildings. Okay, all right. So what I'm doing here, I'm preparing matrices for my analysis because I told you it's much better that you prepare MATLAB that I'm gonna do a matrix, and this matrix is empty right now, and just go calculate and fill the matrix. The first matrix that I'm having right now, I'm calculating the losses for the duration scenario number one. What is duration scenario number one? If you guys remember from last time, we defined the scenarios here. D1 is flood duration scenario for 1 day. And this is equivalent to 9 steps on the curve. And I told you about the 9 steps. And do you guys remember what is 9, 17? Okay, so I'm gonna remind you now, the way that we developed the 3D curve, we said that we need to 100 step, like 100 value. The thing is, from 0 to 100 is 300 hours. So 1 day equivalent of 24 hours. So basically it's like 24 over 300, so it was like the step number 9. Okay. And actually, you can find it out here. Like, let me go to the depth duration Excel sheet. I'm gonna open outside MATLAB so that you guys can imagine what I'm talking about. So in this depth duration sheet, it has the x-axis and the y-axis of the 3D surface. What is the x values and what is the y values? So this is the duration. Look here. The first step was 0 hours, 3 hours, 6 hours. So at 9, at step number 9, it was almost to 24 hours. Okay. So let's go back to the MATLAB code. We have 2 days, that means 48 hours. So let's see, 48 hour is equivalent to the step number 17. Okay, so this is the 48 hour and so on. Okay, so let's get back. So this is the scenarios. So D1 is 1 day up to D5, the 10 days. That's the duration scenarios. And I have here 5 duration scenarios. So let's get back. All right. So I want a matrix for flood duration scenario D1, D2, D3, D4, D5 for 10% of the buildings. And then I have R scenario. What is R? Not scenario. I made R matrix. This R matrix, similar to this one, but I'm not calculating the losses. I'm calculating the loss reduction. So the losses is the total losses. So let's say you calculated the base flood loss without mitigation, it was here, $100,000. Then when you use bumps, it came here, it became 80. So this matrix is gonna have the 80, but I'm not interested in the 80, I'm interested in the difference. So I do 100 minus 80 is gonna give me 20,000, and I store the 20,000 here. That's the loss reduction. And finally, I'm calculating the total reduction. If you look here, this is a matrix. This is not a matrix. This is one single number. So basically this one in the for loop, every time I calculate the loss reduction from building 1, let's say $10,000. And then the next building was 20,000. So I keep summing every one on top of each other until I come with a lump sum loss reduction for the entire community. Let's say it's a $5 or $6 million. So it's going to be one single number here for the entire community. Okay, getting back here. So I prepared the matrix. I put zeros on them. Actually, you can put 0. Here is zeros. I put zeros because it's a matrix. So the matrix is have multiple numbers, so we write zeros. But since this is a single number, so I put just 1 0. Okay, let's start the for loop and do the analysis calculations. I already calculated the base flood loss from previous scenario. If you guys remember, I did calculate the flood loss from when I was doing the flood barriers, right? I don't have to calculate it again here, right? Because I already have done this in the previous step. If you want to do it, you can do it. But we already have done this from previous steps. So I started right away by calculating the losses for flood duration 1 day. Look what I did. I still did interpolation 2D. Why? Because I already guided this function to go right away at the flood duration D1. Right? If you guys remember, I can do 2D interpolation by like going inside this function at X and Y and let the interpolation search for both numbers to get an interpolated value. But right now, I cut this function here. So I asked to calculate at D1. This is D1. So basically, is going to a curve inside the function. Okay. So look at the interpolation that I'm doing here in the MATLAB code. Let me. Okay. So I'm doing 2D interpolation. And for the interpolation, it's a 2D, so I'm interpolating depths with the losses. You'll tell me it's a 3D, but here, when I did this as a 3D surface, once I put D1 here, that means it becomes 2D. Why? Because I'm asking, not going inside all the numbers in the curve, go at a specific section, this section at D1. And D1, I already give it, it's at step number 9, which is equivalent to 24 hours. But if you want to do a 2D, so you'll have to make this 2, and you have to make this something like that. And then you have to give 2 inputs inside this function. You have to give the duration and you have to give the depth. So rather than doing this, I'm making this just 1D. And if you want to go a little bit more and understand this function, you can say help on interpolation. And it's going to open you the help tab and tells you what goes inside this function. And if you want help on interpolation 2D, it's going to tell you exactly how to write what is the input for the interpolation 2D. So here, it tells you what is the input and what is the interpolation method if you wanted to extrapolate, if you wanted to interpolate. If you make this 2, and you said help, so here's the interpolation 2D. Look, first you have to give x, y values, and you look. So you have to have a function that's 3D, and you have to give 2 inputs at what x value and what y value that you want to interpolate. Okay, all right. All right, so let's get back to the 1D interpolation. And look, the inputs that I put, as I told, like the depths and the 3D loss, and I cut at D1. And I did the same thing, D2, D3, D4. You will tell me I can do a for loop here and put the D's in a matrix and making it looping inside the matrix. So you can do this. So you only can write one function inside this for loop. So that's a one way if you want to reduce the steps. But I was like, it's just 5 functions. I just copy paste and I change it like I just change it this value. That's it. But if you want to put these in a matrix and you make another for loop, so going building by building and then go do simulation by simulation, and then you start at simulation number 1 to simulation number 5. You can also do that. All right, so here I put the function, and I'm only doing this for building for the buildings that are 10% of the value. And I told you I cannot do this for loop. Why? Because the building numbers are changing. You know, if all the scenarios have the same building numbers, I can also looping inside, like doing it simulation by simulation. Like I would say, for each building, for each flood depths, and for each percentages of the buildings that are applying the mitigation measure. Okay, so it's gonna be 3 for loops. And I told you we can create the shape files in a way, like I can have the shape file and make fields from 1 to 10. And the field that applying this mitigation measure, I put 1. The one who doesn't apply, I put 0. So that's also one way to do it. And if you guys remember, we have 2 special archetypes. Like there's an if statement here. If it's archetype 1 and 3, because they are on a crawl space foundation, use the flood depths and measure it from the ground elevation. And if it's else, use the flood depths and measure it from the versa floor elevation. So going down here, once you calculate the losses, if you guys remember, I have to multiply by the building value because this is a percentage, but it's not a percentage. I have to divide by 100 because it's a 90 something. All right. So I have to convert it to percentage. And I do the same thing for flood scenario. For duration scenario 1, 2, 3, 4, and 5. Once I finish them, that's still an absolute flood losses. The absolute flood losses doesn't have the reduction. So I'm gonna calculate the reduction later, but let's finish this loop first. Here, the if statement, it says if it's archetype 1 and 3, do this, else do this. You can copy paste this 5 lines and put them here and just change from ground elevation to FFE. And that's actually the amazing things about being organized. So being organized, it makes you easy to just like what I would do. I would take this in a separate one and I make control, like copy and find and replace. Find GE and replace it with FFE. So it makes it very easy to change things. And always name your files, name your lines, name every parameter with something that you can understand it. Oh, you will say FL means like flood, DB means depth, FFE means vertical elevation, S means shapefile that has 10%. So try to make this. And if something that is complicated, make like something like this with the percentage sign and explain it. Explain what are you doing in each section, because you will come. This code, I wrote it in 2019. What makes me remember it after 6 years is that all of these things, every step I'm explaining, this section, I'm gonna do this, this, and that. And you explain everything to yourself, because after some time, you might need somebody to build on what you have done. You might want to remember what you have did. So all this, there's some people, they write their codes, you will never understand anything. Sometimes it's intentional, sometimes it's not intentional, because sometimes you don't need any people. If they got this code, they understand what you are doing. Okay, so it depends. Whatever approach that you would okay with, do it. All right, so here, let's get back. Okay, I calculated the flood losses. The next step, I ended the F statement, and then after I ended the F statement, I calculate the flood loss reduction. Look what I did. For every building, once you finish this analysis and calculate the losses for each building, subtract the flood loss, this one, from this one. You will tell me why I didn't subtract this from the base flood losses. You make me subtract this from loss D5, because I told you the loss D5 is almost the same as the base flood scenario, because here, this curve is almost 100%. So like 99%. So that's why I used the duration number 5 as my base flood scenario.
Okay. I'm on normalization.
What do you mean normalization?
I mean, when you divide by the maximum volume, people are generally taking normalization, like fixing one.
Yeah, but this is actually my maximum flood losses. And I'm referring all these losses to this one. So this one is the maximum. All right, and this one is the by the way, when I did it, the maximum was a little bit higher than this one, but just a little bit. Like we're talking, the other one is like 100%, this is like 99%. Okay. So yeah, so I use this as my maximum. By the way, you can use the maximum that you have, the base one. The base one is here. So you can use it, you will find that the reduction here is like almost nothing. So I found that it's not worth it, and I use the V5 as my base flood scenario. Like if you, yeah, that's for 10 days. So like if you go back to the here, I'm subtracting from loss FR base S100. You can do the same. Subtract from loss FR base S10. That means you are subtracting from the base flood losses for the 10% of the building applying these mitigation measures. Okay, so coming back. All right, so I calculated the flood loss reduction for D5, for D1, D2, D3, and here I have D5 minus D5 is gonna give me 0. I just like try to put 0. That's what makes me here, like, let's go back to the paper. I just wanna make the value when I plot. Yeah, here, this is when I use pumps. Look, this is the base flood loss. All of them are starting from the same value. So to get this curve, this one, that's 0% of the building applying the mitigation measure, all right? But the thing is, all of them at scenario D5, they all start from 0, okay? And then the more that you're increasing, like this one, if the water is gonna stay for 10 days, 8 days, 6 days, 2 days, 1 day,
all right? The more that the flood duration is getting less, the more loss reduction that you're going to have. But by the way, it is not as much reduction as the flood barrier. The flood barrier has much more reduction. By the way, bumping and increasing the flood depth from 10 to 8 days is nothing. Like almost the reduction is 0. Can you see? There is no much difference. All of the curves are on top of each other.
When you are gonna see flood loss reduction, when you decrease the flood to like 1 day, this is when you are gonna see much more loss reduction, when you get it to 1 day and 2 days. But other than that means that these two are not significant. Okay, if the water is gonna stay for a long time, so maybe you don't waste your time on pumping. Okay, all right.
Net reduction is linear, it looks like, right? I mean, I see some chart.
The thing is, let me, but because I only did 5 scenarios, you know, if I did many scenarios, there's gonna be a curve. Yeah, but this one is the same. Like, if I did actually 2 scenarios, it's gonna be line, but the more that you have points, because that's too much analysis. When you run it, it's taking a few hours. So the more that you increase the scenarios, the more it's gonna take time, because you are doing interpolation and you are doing a lot of stuff. Okay. So. And then the next step, I'm calculating the loss reduction. And the loss reduction, as I said, it's not a matrix. And the way that I'm doing it, I'm calculating, this is like a storage, I'm storing the number in. So I'm asking MATLAB, once you calculate a flood loss reduction for building number 1, store it here. So it's in the storage. And once you calculate for building 2, put it back in the storage and plus it was every number in the storage. So this number is increasing in each for loop. Because every time you calculate $100,000, it's gonna be stored here. And it's gonna be here. And when you get to the next step, and the next step is like 200, it's gonna find 100 and plus 200 is gonna be 300. So each step is keep getting changed. And I'm doing this for D1, D2, D3. And at the end, once I finished, all what I'm interested in is the loss reduction total from flood duration. And I'm putting this here. Oh yeah, I put them in a matrix. Okay. So look at this one. So every one of these is a single number by itself. But the thing is, after I finish this, I want to take all these values into Excel sheet. So what I did, I converted this number and I put them in a table. So flood loss reduction from flood duration 1, put it in this field, and then 2, 3, 4. So I put it them in one single matrix. And by the way, I was thinking maybe I did this. I tried to put all the loss reduction from all the building percentages and from all the scenarios in one big matrix. I mean, like at the end, I want to have a table like this. Never. And I have here D1, D2, up to D5. I want to have here the 10% of the building, 20% of the building, 30%, up to 100%. All right. And I want to know what is the flood loss reduction at each one. So from number 1, I have all these numbers. So I put them in the first row on the table. But the thing is, I found out here's one, right? So it's going to be on only one single table because I have here S10. Maybe at the end, you can organize all the results from all the percentages and put them in one single table. The way that I did it, I copy paste them from MATLAB one by one. Like for building 1, I put it in an Excel sheet, building 2, but you can make MATLAB do it for you. All right. Okay. I went down to see if I look here, I put here 1. I thought that when I did for 20% of the building, I changed this number from 1 to 2. And when I did 30% of the building, I changed because this is column number 1. So I'm saying column number 2, 3, but I didn't do this. Look.
If I go here, this is a still one. Why?
Because I named this S20. So I named this just for S20. Maybe a good way to do it, you can remove S20s and you make it loss reduction total V. That's gonna be general. And you put 2, 3, 4. So at the end, once you finish, it's gonna be all of them in one big matrix. So you see, the way that I look at the code, every time I get more ideas that can decrease the number of lines. So that's how coding work. All right, so let's get back here. So once you did this, you finished with 10% of the building. All right, so right now we are done with the first one. And actually you are done with the flood duration task. So all what you are gonna do next, you are gonna copy this, Control C, and you open a new sheet, and you are say Control V, and this is your code. And all what you're gonna do, Control F to find, and you are gonna find S10 and replace it with S20. And I'm gonna say replace all. And then you are done with the 20%, and then paste. And then you do it 30 and paste, 40 and paste. So how many lines we have here? We have around like 50 lines, but actually most of them is, some of them are copy paste. Like this one, you copy paste and you just change D2, D3, whatever. Same thing here. Let's get back. All right, so once you finish D20, you will come here and then you write one line and you say, assuming only 20% of the building are using bumps, to know what is this section is writing, and then paste. And once you paste, you come to the next here, assuming 30% and paste the 30%. And right now we are done with all until we go to the 100% of the buildings. So right now we are finished with bumping. This lines of codes, you don't have to do it. Like when I was publishing this paper, the reviewer asked it to do some extra analyses, and I put them in the same MATLAB folder. So you don't have to write these parts. And here, that's what we need. This one, this part. So right now we are done with the flood the water duration, the pumps, right? Does anybody have any questions so far? It is just the 50 lines of codes. Half of them is like similar, copy paste. And other than that, you are gonna copy the 50 and put and copy and put it back in the code. That's it for the bumping. And once you finish the bumping scenario, I want you to generate this curve. And the same thing for the flood barrier, because once you finish the analysis, you will be able to do this curve. And by the way, this curve is based on the absolute losses, not the flood loss reduction. Because each one of these curves tells you how much total losses is gonna have. And you can see the reductions from the curve, like how much reduction from each one. So how can you plot this? You have to generate this table. Once you generate this table, you are gonna have D1, D2, D3. So you are gonna have, and by the way, I named them 1, 2, 3. I didn't put flood duration 1 day, 2 days, because this is how MATLAB works. Okay. I mean, so I can't have one single step, but you can do it if you want. Like if you want to put it like 5 is like 10 days, but I put it like as a scenario number 1, scenario number 2, scenario number 3, 4, 5. And by the way, when I plotted this was scenario number 1. Okay. Scenario number 1, when I plotted this way and I made D1 scenario number 1, not D5, because this one is D5. The curves was like all these was here, and they all are coming to a specific point here. So I thought it might be look much better if I start from 0 and the readers can see how it getting decreased. Okay. The other way wasn't like not that good. We always read from this way to this way. So I swap these. If you want to name them differently from the MATLAB code to avoid this, you can do it. But you guys understand what I'm talking about? Okay, I'm gonna explain it again. The thing is, the D1 is for 1 day.
24 hours, 1 day. And then this is 2 days, and this is 10 days. That's D5. So 10 days should be here, and 1 day should be here. So these curves is gonna have zeros here, and the flood or some like zeros here, and it's gonna be going down like this. Okay, but what I did, I flip it. Okay, that's the thing what I did. So you are plotting this table, and actually that's a simple plot. Like you give MATLAB the table and you say plot X was Y. This is X. Okay, this is X. And this is Y, and plot them together or whatever. This is X and this is Y. All right. So actually we are plotting this as X values, and this is the Y value. Once you plot them, it's gonna give you all these curves plotted. You can actually plot them in Excel. Okay, so it's gonna plot you something like this. What we are plotting this function. Like if you go to MATLAB, we are plotting not the total, this one, the flood loss. Actually, you know what? We are plotting the total. Not the because the reduction is for each building, but we are plotting the total floods. Let me just think about it. So we are plotting, here's the reduction. This is the reduction, and this is the reduction total. The thing is, each one of these scenarios is not for a building. It's for the entire community. Like this value, like let's say this value, that's like around $87 million. This is the amount of losses, not the reduction. If you use a flood barrier of a height 1 meter for every building within the community. Okay, so that's a basic loss. So you need to do something if you want to develop these curves. Once you have this matrix, I believe this is what I have done. This matrix, you have the loss reduction for scenario of pumping for 1 day, and this is for every building. You need to get the loss reduction total for all the buildings. Not the loss reduction, the amount of losses total. This is going to give you for every building. Let's say you are going to have a column here. This is building one, sorry, this is building 1, 2, 3, 4, up to whatever. Let's say 2,800 building. Okay, so you will get the losses for building number 1 and the losses for building number 2, 3, 4. Once you are done, you need to sum all these losses to get the total loss for the entire community. Okay, let's say this number is, as here, $87 million. Okay, that's one number for D1. You need to do it for D2 and D3 and D4. So we need to develop a line of code here that not calculate the reduction total, calculate the loss total. Okay, so there will not be R here. Or that's one way to do it if I want to do it in MATLAB. Or you want to do it, you get this value, I take it in Excel file, and in Excel file, I take the sum of all the losses. Okay, so that's a one way if you want to do it. But if I want to do it here, I would write another line of MATLAB code. Let's say I'm going to write it here. Okay, I'm going to take this copy and I'm going to write some lines here. All right. And I'm gonna not calculating the reduction. I'm calculating the losses total from D1 S100 and this is gonna be equal to the loss total D1 S100 plus not the loss reduction, the loss at D1 from S100, this line, okay? So basically, every building that you calculate the loss for is gonna keep calculating building by building and store it in this new function. So the difference between this, the one in the top, that's the loss reduction. This is gonna calculate the losses total at the community level. Okay, do you guys get that? And you do this for D2, D3, D4, 5 lines until you get to D5. And definitely you have to define the matrix up there. Like you have to define another matrix here. Like let's say another line here. And you prepare it to be zeros. Like you're gonna delete this. And this is gonna be 0 and you define 5 of them. All right. So that way you calculate the loss total for all the building within the community, not the loss reduction as a single one number, okay? And it's gonna give you the same thing. If you calculated the total loss at the community level and the total loss at the community level with mitigation as a one numbers and you subtract them from each other, it's gonna give you the same value in the flood loss reduction, okay? All right, also one way to do it, another way, like if you don't wanna do whatever I said here, you can do this. You already calculate the loss reduction, right? As a one single number for all the community. And you already have the loss base for the entire community because we already calculated. If you plus the reduction, if you subtract the reduction from this is gonna give you the total new losses. The thing is when you apply the mitigation measure, the loss is not gonna drop to 0. It's gonna get less by a specific amount, this amount. So this is the amount is gonna get less. So if you subtract it from the base, it's gonna give you the new amount of losses that you have. So there's multiple ways that you can do this, all right? Okay, so that's it for now. And I'm not gonna overwhelm you with more stuff today. Maybe I will start the next part, next lecture. So I wish if you guys can, like, in the next few days, start writing this code, as I said. The class project, you can do it yourself, or you can, if you want to team up with one of your classmates, that's fine. At the end of the class project, I want the MATLAB code. So the assessment is going to be on 2 parts. First, the documents that you're going to give to me, and I told you I'm going to upload the template. If you guys took the advanced structure analysis with me, it is the same template of the ASCE paper that I gave to you, but I'm going to upload it again. It's like the template is like two columns. When we write the paper is like 2 columns, and the abstract is on the top. But I'm gonna give it to you, and you just fill inside the template. If you want to do it in a regular Word file at first, and once you finish, you want to convert to the template, that's fine. Okay, so the assessment is gonna be on the submission files, MATLAB files, Word files, Excel files, whatever files that you have. Basically, I'm gonna go through your Word file. And if I found the results are triggering, I'm gonna go track your MATLAB code. I'm gonna give it a look, a general look in the MATLAB code, but if the result is triggering, I'm gonna check how much errors do you have in MATLAB code, stuff like this. That's one part. The next part is gonna be a presentation. So you have to have a presentation to present your work. How did you start your analysis? What data that you used? And show me GIS files, hazard map. I gave you all these files. Like, you guys look at the drive, you will find the hazard map, you will find the building points. I want to see, because when you present the project, you have to show me what city are you working on. So show me the city that you're working on, show me the buildings that you have, show me the hazard map. So you have to show all these information in the final paper for this class project, okay? And also in the presentation, when you present, like, don't show me the result right away. You have to tell me, oh, this is Lumberton City in North Carolina. You can read some of the papers that I published. It has lots of information about the city, some images about the location of the city. So try to use this information for your presentation. And then you tell me, oh, this is the buildings. And I have how many numbers of buildings. This is the archetypes of the buildings. You show me all this information to make sure that
we understand what are you talking about. Same thing when you write the paper, you have to explain first in the abstract, what are you doing? I'm doing a flood risk assessment for Long 10 under hurricane, under a flooding event induced by Hurricane Matthew in 2016, and tell me the component of the assessment. Like I modeled the hazard this way, I modeled the exposure, the vulnerability, I did mitigation, and in the abstract, you mentioned a significant thing that you find out about your analysis. That, for example, mitigation analysis using flood barriers is much more significant than bonds. Or when I combine flood barriers with elevating components is much more significant than other mitigation measures. That's what the abstract about. When you write an abstract, you mention what other people have done before, and you mention what are you doing and what is your contribution, what significant things that you have found. Then in the introduction, I don't want introduction and papers, we usually put some literature review. That's what we put. We put like what other people have done and what is lacking, what are the gaps, and how we are going to address these gaps. So maybe you look at my previous papers because all this was published. I'm showing you the paper. So look at the introduction. I don't want a long one, just like maybe 3 paragraphs or something in the introduction. It was, I don't know, 10, 15 reference at least. And show me that you read, or not reading, but at least looked at some papers on what we are doing. Maybe my papers, look at them. Okay, it's gonna give you a full idea about what we are doing. Then after the introduction, there's the methodology. Tell me how you model the hazard. Well, you will tell that I have this hazard map based on the grass, whatever, because I will give you the hazard. Okay. Tell that I already use the hazard map that already there and cite my paper. That you, because if at some point you want to publish this paper, if you put a lot of effort in this paper, you can publish it. Okay. So you tell that I use the hazard map that is already in the literature and I got it from this research. And then the building inventory, I got it from the National Structure Inventory. You tell the methodology what at each step, what did you do in each step. Once you finish, you tell the methodology for the mitigation analysis, the methodology for the risk assessment, how you calculated every calculation, because we did a lot of calculations. See, we are like in line number 2000, whatever. So you mentioned every step that you are gonna do, but if you want, that's a method, that's a technique when we publish. If you want to publish this paper, not as a case study, you have to show, because when we publish papers, this is how the paper get ranked. Papers that are contributing with new methods to the literature, it's called a methodology paper. That is the best paper that you can publish, that you are developing a new method or a method that can be applied to any community, okay? But if you start everything mentioning that everything that you are doing, that you are saying, oh, I applied this to this community is gonna show up as a case study. Case study is the second tier of the papers. That what you are doing cannot be applied to any other cases. So the way that I do it in my papers, I mention the method in a general way without talking about a case study at all. This is how we calculate losses, this is how we calculate risk, and this is the general formulation of everything that we are doing. And then the next section, I mentioned that I applied my general method to a case study to show how this method is applicable in real life. Then in the case study, I start mentioning what is the case, what is the city, the geographical location, the hazard modeling, and everything about the case study. Then I mention the results, how my application of the method that I have on the case study is giving me this result. Look at this paper.
I believe most of the papers that I have is something like this. It depends on the nature of the paper, but look, let's say, okay. So here we have the abstract and then an introduction. I told you it has some literature review, maybe some data, figures. And then the methodology. Look at the methodology. I don't think I mentioned any case study in this methodology. I put a general method. I put a flow chart showing exactly what I'm going to do in the MATLAB code. Okay. And then how I did modeling of the buildings, mitigation measures. I put some pictures. And then another algorithm This algorithm actually is the thousands of lines of coding that we have is in this flow chart. I made it in a landscape, and by starting reading all the information, doing all the mitigation and the loss analysis and everything. So I put it in one big flow chart. This flow chart, by the way, it took me a few days to build it. Can you imagine one figure can take you many days to build it? All right, so, and here's like an picture of a bomb, and here's if I want to elevate water sensitive components. I'm just showing that the mitigation that I investigated are realistic and other communities implement. Showing like some pictures of the bomb. Here's some like vision of what components that can be elevated. And then, yeah, here's illustrative example community, which is the case study, Lumberton, North Carolina. And then I start mentioning a lot of information. The city of Lumberton was used as a test bed. And then I put the location of Lumberton, I put the buildings and their archetype from one like color coded based on their archetypes. And then I put some fragilities that I have that I used. And then I believe the results section, yeah, here. Okay, here's the results. Like I put all the results that I have for Lumberton, building level mitigation measures. And then first results was for the flood barrier. Second was the bombs. And third was resilient construction. I called resilient construction. This section is for elevating the components. Like the thing is, when you want to elevate your AC or want to elevate some components, that comes before the disaster. You plan before the disaster how it can be resilient. So you start elevating the AC system from the crawl space to the attic. You elevate your AC. You do some resilient construction. So I explained this section here, and going down, I explained everything. And I put all the results, the hazard analysis results, and also put the mitigation at the community. I showed some figure, how's the damage and losses look like. And this is the mitigation scenarios. If using a flood barrier, pumps, all the scenarios that I have. And then finally, I have the summary of the results here. And here I put some figures, shows if we used like every one of these is one of the selected scenarios that we have, and then that's it. Okay, so this is how papers look like, and I'm not asking you to get me something like this, maybe just 5 pages, 6 pages, based on how many figures you want to present, and try to put as much effort as you can, right? Okay. All right, so that's it for today.
Use the same figure, but long range.
Yeah, you can use figures from here. The thing is, in your GIS, when you the code, you can get even figures better than this.
Yeah.
Yeah, whatever you want. Yeah.
But I mean, if it was representing the same value, it's okay.
Right, sure. All right, sounds good. See you guys next time.